So, for the last 3 days, we've talked about solving systems by graphing. That's what we did up on these boards. We talked about solving systems through substitution. That's what we did the last 2 days. Today, I'm going to teach you the third method for solving systems of equations. And it's honestly like kind of personal preference whether you like substitution or elimination better. There are certain circumstances where one is better than the other or easier to do than the other, but they work for whatever problems or whatever systems of equations you're trying to do. Okay? Yes? Substitution is what we did the last 2 days, where you isolate a variable, you plug it in to one of the equations. Okay. Graphing. So today, we're going to talk elimination. We're going to start with this word problem. We're going to set it up like every other word problem we've ever done. So I'm talking about a talent show we're selling tickets for. There are senior citizen tickets and student tickets, and there are 2 days of sales. One day they made $102. The other day they made $126. We want to know what is the price each of one senior ticket and then of one student ticket. When we set up equations in our word problems, because I know we're still kind of struggling with the word problems, the first thing we want to do is look at that very last sentence with the question mark that's asking us, what are we supposed to find here? What are the two variables that I want? What? Senior citizen tickets, specifically the price of senior citizen tickets. Oops, not K. Senior tickets. And then the other one, Y, should be the cost of a student ticket. So that last sentence, the one with the question in it, is telling us what our two variables should be. Then I look for totals. On the first day of this talent show ticket sales, they sold 4 senior citizen tickets, 5 student tickets for a total of $102. To set that up, I would say 4 times whatever the cost of a senior ticket is, which is X, plus 5 times the cost of whatever a student ticket is, which is Y, equals $102 in sales. What about day 2? What does that equation look like? Yes. So I know that the total they sold on day 2 was $126, and they sold 7 senior citizen tickets and 5 student tickets. This is the same no matter whether you're doing substitution or elimination, setting up these equations. Do we feel good about that? We see where those numbers came from? Fantastic. Okay, so now I see these two equations, and I'm in my substitution brain thinking, is there something easy to isolate? Not really. Like, we could do it, obviously. We can always do substitution or elimination, but there's nothing here that doesn't have a number in the front of it, and that's what I like to see when I do substitution. So instead, my brain goes to elimination, and let me show you the steps for elimination. Elimination is essentially one big addition problem. So I want to add these two equations together and have one of my variables cancel out. Do we know how we cancel things out? We add its opposite. So what I want to do is I want to take a look at the x's or the y's and figure out how can I get them to cancel each other out. The way that I'm going to do that, I'm going to take my first equation and I'm going to multiply it by something. I'm going to multiply this entire top equation by a -1. The reason I'm doing that is because when I multiply this 5y by -1, it is going to cancel out with this positive 5y. Let me show you what it looks like. I'm going to multiply -1 times 4x to get -4x, 5y times -1 to get -5y, and 102 times -1 to get -102. Once I've done the multiplication, I no longer need that original equation anymore, so it might be helpful for you to just kind of cross it out, because this is the new equation we're looking at. Okay, you don't have to go crazy. Now take a look at these two equations. I'm adding them together like I'm in elementary school. I draw the big addition bar with the plus sign. I think about, okay, what does 7x minus 4x get me? 3x. What does 5y minus 5y get me? 0. That was my goal for elimination, is to get one of these to cancel out. We call that having opposite coefficients. When it's the same number but opposite signs and they cancel out, that's opposite coefficients. Then I have my equal sign. And then 126 minus 102 is 24. Yeah, and then if I see, all I'm left with is 3x. Oh, hello. 3x equals 24, which is pretty easy for me to solve. Like Cody said, I'm going to divide this by 3 to get x equals 8. Now, am I done? What do I still have to do? I got to plug it back in and find the y. Just like I did with substitution, the last 2 steps have not changed. I still need to take this number. I still need to plug it into one of my original. I have 3 options that I can use. I usually just use one of the original 2 equations. So let's just use, let's use that original one. Maybe you crossed it out. Maybe you want to use, that's okay, because you went crazy with your crossing out. You can use the second one if you want to, whatever works for you, whatever you can see. I'm going to do 4 times 8 plus 5y equals 102. This is 32 plus 5y, or 5y equals 70. Sorry, I should probably do my work, shouldn't I? Yeah. And then divide by 5, y equals 14. So as an answer, remember our answers should be coordinates. So 8, 14 is my coordinate. What does that mean in words?
8, or 1 senior ticket plus $8 and 1 student ticket plus
I ran out of room here, but yes. Any questions on that?
No.
Let's recap the steps that we just did. Step number 1, after we have already written our equations out, was to get those opposite coefficients with the intention that one of our variables cancels out. So step 1, get opposite coefficients. That means one variable, so either the x's or the y's, will have the same number but opposite signs. Can we read? Sorry. One variable, so either the x's or the y's, not one of each, with the same number in the front, but opposite signs. One positive, one negative. You will always be able to do it. Step 2. Once we have opposite coefficients, we add our equations together. You should be adding x's together, y's together, and then whatever's on the other side of your equal sign together. One of the variables should cancel. If one variable does not cancel, you didn't do it right. You need to multiply by something different to make it cancel. Once we have that, it's essentially the same as substitution. We're going to step 3, solve for whatever remaining variable there is, and then rinse and repeat. We substitute and we solve. That's what we did here, right? I multiplied by this -1. I added my equations together. I solved for whatever variable was left. Rinse and repeat. I substitute. I solve. Any questions on that? So why would we ever use elimination? We already have so many methods, Miss Lise. Well, it's better than graphing. Imagine trying to graph those numbers that are in my problem, like 102, 126. That's not something I want to graph. So it's nice when there's large numbers. So maybe I say good for large numbers. It's also good when our equations are not in slope-intercept form. So if they're not in a graphable form, we wouldn't want to graph them, right? Why is it better than substitution? Well, in this problem that we had, it wasn't easy to isolate a variable. So it would be better than substitution if a variable, is not easy to eliminate, to substitute, isolate. Or, just to save time, if it's faster because you already have opposite coefficients, it might be worth it to use elimination. Any questions on this? Oops. So your homework, your quiz, your test is going to not only have problems where you have to use substitution, you have to use elimination, but it will also have problems where it's your choice. Whatever you want to use, whatever you feel the best using, you're going to have to use your own thought process to figure out what one works for you. Let's take a look at these examples. I cannot skip any of them. We have to go through them all. All four. All right, example 1. My first step when eliminating is to get opposite coefficients, which means same variable, same number in the front, opposite signs. Do we have that here? Which variable?
Y.
The y's. So I'm going to add my two equations together. Because these are already opposite coefficients, all I have to do is cancel those out. What I'm left with is 2x plus 6x, which is 8x, and 17 minus 9, which is 8. Divide by 8, x is 1. First step done. Now what do I have to do to finish this? Plug it back in. I'm going to take x equals 1 and plug it into one of my originals. 2 times 1 plus 5y equals 17. And we're done. I can write that as a coordinate pair, of course. 1, 3. What do we think? Do we like this method? Some of us are going to like it better than substitution. Some of us are really going to like substitution more. It is kind of personal preference, except sometimes it's pretty clear which one you should or shouldn't use. This one seems faster? I agree. Sometimes it seems faster. Personally, I do substitution all the time, but you're going to figure out which one you really feel the most comfortable with. All right, example 2. Do I have opposite coefficients right now? So how am I going to get those opposite coefficients? Autumn. Perfect. What are you trying to cancel out here? If I multiply this first equation by a negative 2, watch what happens to the y's. The x's are negative 6x, but the y's become negative 4y. That is a positive 4y and a negative 4y. That is my goal. I can ignore this first equation now that I'm done with it, and I'm going to add together the other two. I multiplied by a negative 2 to that first equation so that I could get this new equation that has opposite coefficients with the 4y and the negative 4y right here. We see it? So those two things cancel out when I add them together. 4x minus 6x is negative 2x, and then negative 2 minus 2 is negative 4. Divide, x equals positive 2. What do I do with that? Plug it back in. So this is 3 times 2 plus 2y equals 1. 2y equals negative 5, or y equals negative 5/2. So imagine doing that on a graph. Do we want to work with fractions all crazy willy-nilly? Not particularly me, so I would not want to have to graph something like that. So that coordinate 2, negative 5/2. Feeling okay about this? I'm going to throw the weird ones at you now. They're going to be mixed in with all my other problems, so we're going to start just like we always would. What? How are we supposed to do this? What do we think?
Oh, I know.
I want opposite coefficients. I don't have them yet. What am I going to do? I don't want to divide. I always want to multiply. Adriana? Positive 2? Which one, the top equation or the bottom equation? Let's multiply the bottom equation by a negative 2. So that's going to get me a negative 2x, a negative 6y, and a negative 18 on the other side. Okay, I'm going to get rid of my middle equation because I'm done with it, and I'm just going to add the top one and the bottom one that I have. What happens here?
0.
2x minus 2x is 0. 6y minus 6y is 0. There's nothing left on that side, so I write a big fat 0 there. What's left on the other side? 18 minus 18 is also 0. Do we remember my two special cases? No solution or infinitely many? Which one is this? I'm hearing a mix. Who thinks it's infinitely many?
Oh, I agree.
Who thinks it's no solution? Okay. This one is infinitely many solutions because, why? Is true or false? So anytime we end up with a true statement, remember, what did I say yesterday? Your variables have to be gone. We cannot say infinitely many solutions if there is still an x in your problem. I also don't want to see you just write the word true. I have to see infinitely many solutions. Infinitely many solutions. Okay, one more. Do I have opposite coefficients? What do I need to do? We always multiply, never divide. On the top or the bottom? Let's multiply that top equation by a negative 6. What happens? I get a positive 6x. I get a negative 12y. And I get a negative 42. I'm adding these two equations together. What happens on the left side? I get 0 because negative 6x and 6x cancel. 12y and negative 12y cancel. And what about on the right side? What do I get? 72 minus 42 is 30. Why is this no solution? Because it's a false statement, therefore no solution. Any questions on that?